So hi guys, so for today we will be having shafts or shaftings in machine design. As I may share with you, this is my favorite topic in machine design. So the shafts. I still remember all the formulas in machine design and most specifically in shafts. And as a mechanical engineer, dapat nasa dugo nyo ang formulas ng machine design. Mainly because machine design is one of the three major subjects in our board exams. So we have power and industrial plant, power and industrial plant engineering, and then we have mathematics and basic engineering sciences, and then lastly we have machine design. So and then shafting is very important because there are a lot of formulas here in shaft, so I cannot wait to introduce to you, to share with you, most especially the one with about main shaft, line shaft, and short shaft. That is actually my favorite formulas, the one with the PSME code for shaft. So I will be sharing it to you later with a simple sample problem. So let's start. So we have here, first is shaft power. So I will be introducing two units here, the SI unit and the English unit, so that aware kayo if you will be having English unit na given and SI unit na given. So let's start. We have here shaft power formula in SI unit, which is simply 2 pi Tn, wherein make sure that you know this is an empirical formula, so it is a must that you know the specific unit of each component. So we have here P, that is power, that must be in kilowatts, or if you use the power formula for SI unit, which is 2 pi Tn, wherein T is torque in kilonewton meter, and then we have NS is speed in RPS or revolution per seconds. Your resulting answer must be in kilonewton meter per second or kilojoule per second, or in simpler terms, that is kilowatts. So again, if you use the power formula in SI unit, power is equal to 2 pi Tn, wherein torque is in kilojoule, or that is kilonewton meter, and then you have N in RPS, your resulting unit must be in kilonewton meter per second, or kilojoule per second, or simply kilowatts. So next we have here power formula in English unit. So that is 2 pi Tn with divided by 33,000. So if you use this formula, you will be having a result of power but in HP. And then you have to use torque in pound-feet. And then your N or speed must be in RPM. So unlike in SI unit, we will be using RPS, and then torque is kilonewton meter, and then our resulting power is in kilowatt. So in English unit, resulting power is HP or horsepower, and then the torque is in pound-feet, and then our N is in RPM. So I hope the difference is clear. So we have here the torque. I already mentioned this as a part of the formula for power, which is 2 pi Tn, wherein T is torque. So now I will be introducing to you the formula for torque. So in such a case that there is no torque given, you know how to solve for the value of torque. So the formula for torque is F times R, wherein F is applied force and then R is radius. Other books are using FD over 2, wherein D is the diameter. that is why a simpler formula is FR, because radius is equal to diameter over 2. So if you see that other books uses FD over 2, that is all right, because that actually simply means F times R, or applied force times radius, since again radius is equal to diameter divided by 2. So if you see in a given that there's a radius and then you need to find, there is a diameter or radius and then vice versa, um you can solve for the torque if it is not given, provided that you have the applied force. Again, the unit, it will depend upon the unit of the torque will depend upon the unit of the force and the radius. For example, your force is in kilonewton, and then your radius is in meters. So your resulting torque is in kilonewton meter. So in English unit, if your force is in pound force and then your radius is in inches, your resulting torque is pound force inch. But then in the provided formula for power, you need to use pound force feet. So you still need to convert pound force inch to pound force feet before applying it to our P power is equal to 2 pi T N over 33,000 to arrive at the HP power. So to arrive at a unit which is horsepower, or to use the English formula for the power, you must always be mindful of the units that you are using, since I mentioned earlier that is an empirical formula. So let's proceed to the next. My first video about regarding machine design focuses on stresses. So here we will be focusing on stresses in shaft. So our first focus is stresses in shaft when subjected to pure torsion. So we have here SS as the nomenclature. So here's the formula. So for solid shaft, again, we have TC over J, wherein T is in torque, and then J is the polar moment of inertia, and then C is distance from neutral axis to the farthest fiber, and then D is the diameter of shaft. So for the solid shaft, upon substituting the value of C and J, we arrive at 16T over pi d cubed. So for solid shaft, stresses of solid shaft, we have 16T over pi d cubed. Now we proceed to the hollow shaft. So again, the formula is TC over J, but then it differs with the solid shaft in the matter that it possesses outside diameter and inside diameter. So the formula is 16T DO, wherein DO is outside diameter, and then over pi DO to the fourth minus DI to the fourth. So take note that in the numerator, we have DO, which is the outside diameter. So next we have another formula, torsional deflection. This is denoted as theta, so as you can see. And the answer here is in radians. So please take note of that. I know there are a lot of students or even engineers that is very careless most of the time. For example, you keep on solving, for example, a problem. You keep on solving, but you didn't notice that your calculator is in degree, but you need to have it in radians. So if you decided to use your calculator in degree, make sure that you know the conversion of degree to radians. And then radians, if you decided to use calculators in radian mode, you have to know the conversion of radians to degree. So that's my suggestion lang naman. So we have here the formula, theta, which is torsional deflection, is equal to TL over JG, wherein the answer again is in radians, wherein L is length of shaft, T again is torque, and then we have J, polar moment of inertia. So I provided here the formula for polar moment of inertia for the solid shaft, which is pi d fourth over 32. And then we have here for the hollow shaft, since again it possesses inner and outside diameter, we have here pi times do to the fourth minus di to the fourth over 32. And then in such a case that G, or modulus of rigidity and shear, is not given, and then the given is steel, kindly remember that you may use 11.5 times 10 to the 6 psi, or pounds per square inch, for steel. So other books I think is using 12 times 10 to the 6 psi. So in such a case that you cannot solve it in 11.5 times 10 to the 6 psi, you may use the 12 times 10 to the 6 psi. Earlier, we mentioned about stresses in shaft when subjected to pure torsion. Now, I will be introducing to you stresses in shaft when subjected to torsion and bending loads. So, again, we denote this as SS. Or, again, pwede naman kayong gumamit ng ibang nomenclature as long as you know that is for the stress of shaft and subjected in pure torsion, or subjected in torsion and bending loads. So now we have here again for solid shaft, 16T over pi d cube, that is for pure torsion. So as you can see here, we have 16 over pi d cube. And then the torque is associated now with moment. Since we have bending load, we will be utilizing moment. So the formula for tensile or compressive stress, we have here 16 over pi d cube multiplied by moment, multiplied by the quantity of the moment, plus the square root of moment squared plus torque squared. So again, if you are using SI unit, make sure that there is uniformity in unit, same as in English unit. So for the maximum shear stress, we have 16 over pi d cube multiplied by the quantity of the square root of the moment squared plus the torque squared. Next, we have for hollow shafts. So again, this is almost similar with the solid shaft, but then again, we have here the outer and inner diameter. So our formula, instead of d cube, we have do to the fourth minus di to the fourth. So as a recommendation, you may memorize the formula for solid shaft and then just recognize the difference between solid shaft and hollow shaft so that hindi ganun kadaming formulas ang sasaolohin nyo. So that's only my technique. It depends on your convenience and kung ano yung effective sa inyo. So, next we have strength of shaft with assumed allowable stress. So, take note with assumed allowable stress. And then, this is based on PSME code. And as I have said earlier, this is my favorite formulas. Favorite empirical formula. Again, paulit-ulit kong sasabihin, these are the formulas that nasa dugo ko na. Hindi ko na siya makalimutan. So, first, we have mean shaft. The formula for power is equal to d cube n over 80. So, 80 is the denominator for the mean shaft. Kung mapapansin nyo yung difference niya as I discussed the line shafts and the short shaft. So, the power must be in HP. And then, to arrive at that power HP, you must be using the inches for diameter and then RPM or revolutions per minute in the speed portion. So next we have line shafts wherein the denominator is 53.5. Again, power must be in HP or diameter must be in inches, and then the speed must be in RPM. So I have here a sample problem for line shaft. I want you to know how to solve or how to use it, how to use the formula to further visualize the formula. So I have here a sample problem. So the problem states that a line shaft is to transmit 200 HP at 900 RPM. So find the diameter of the shaft. So again, it is mentioned that it is for line shaft. Our formula for line shaft in solving the power is d cubed n over 53.5. However, the given power, we already have a power given which is 200 HP. So luckily, we don't need to convert kilowatt to HP or any unit of power to HP since the given is already in HP, which is the required unit for our empirical formula. And then we have the 900 RPM, which also already in RPM. So what we need to do is to substitute it to our formula and then getting the cube root of the resulting answer, and then we arrive at D, or the diameter is 2.28 inches, because our empirical formula states that if you use power in HP and then speed in RPM, the resulting diameter is in inches. So I hope that is clear. So since I mentioned that there is 3 categories for this topic in PSME code, we have next the short shaft. So my clue here is, of course, you remember 80 and then 53.5 and then 38. Remember that 80 is the biggest, so that is for our main shaft. And then for our short shaft, we have the smallest, the 38. So the line shaft is the remaining, so that belongs the 53.5. Again, my only reminder is always to take note of the unit. Remember, the power is in HP, diameter is in inches, and the speed is in RPM. So, to end this content, I will be discussing one problem related to stress in shafts induced in torsion and bending. So, the question is, a round steel shaft rotates at 200 RPM and is subjected to a torque of 225 Newton meter and a bending moment of 340 Newton meter. The allowable shear stress is 40 megapascal. So find the diameter. The question is find the diameter. We are provided with the allowable shear stress. So that is SS. So since we are provided only with the shearing stress, we need to use the formula for the shearing stress respectively. So that is 16 over pi d cubed multiplied by, since this is a torsion and bending stresses, we have to use the given moment and then the torque. So the formula 16 over pi d cubed multiplied by the quantity of the m squared or the moment squared plus the torque squared. So as I have mentioned earlier, the uniformity in unit is a must. So we have megapascal, so that is meganewton per square meter. That is our shearing stress. But then in this solution, I decided to use the kilonewton per meter squared. So that means the 40 MPa is equal to 40,000 kilopascal, which is equal to 16 over pi d cubed, wherein our 340 Newton meter moment is substituted as 0.3 340 kilonewton meter, and then 225 newton meter is substituted as 0.225 kilonewton meter. So simultaneously solving this, or you may use also the shift solve feature of your calculator, we will be arriving at 0.0373 meter, or it is equivalent to 37.3 millimeters. So I hope I was able to help you, or I was able to share something na mapapakinabangan nyo in the future. So yes, we are done for today. If you wish to have a copy of this PowerPoint presentation, and if you also have some further questions or clarifications regarding the topic, kindly email me at ryannicole05@gmail.com. Thank you!